Hey guys, what's up? It's Mrs. Bergman here. I'm going to teach you a little bit today more about ellipses. We're going to review what we learned on Friday when we basically just talked about the equations for ellipses. We're going to do a few more practice problems and go over maybe a few things that you had trouble with on the homework. And hopefully you've already submitted your homework. If not, find the directions to do that in your email and make sure you get it submitted. All right, first things first, let's go over our two equations. So we have an equation for a horizontal ellipse, which basically means it's longer horizontally. The major axis is horizontal. Or a vertical ellipse, which basically means it's longer vertically. The major axis is vertical. All right, the minor axis is going the other direction. The major axis ends on the vertices. The minor axis ends, the endpoints are the co-vertices. And where those two major and minor axes, where they intersect, is called the center of the ellipse. The focus points are on the major axis. And we have some important values. So the A value represents the distance from the center to the vertex. The B value represents the distance from the center to a co-vertex. That means that the entire major axis would be equal to 2 times A. The entire minor axis would be equal to 2 times B. Last but not least, the distance from the center to a focus point is equal to C. All right, our equations are basically the same thing, whether we're talking about vertical or horizontal. The only thing that differs is where the A squared and B squared are in the denominator. So for a vertical equation, A squared is under Y squared, whereas for a horizontal equation, A squared is under X squared. A squared is always going to be the larger number because it's measured along the major axis. All right, let's get started. So this first one, we want to graph this ellipse. The first thing you need to do is figure out the center point by finding H and K. Remember, the center is always at the point H, comma, K. So in this case, it would be 6 and -3. Remember, if I plugged in -3 for K into this equation in either one, it would be Y minus -3, which simplifies to what we have here, Y plus 3. Okay, so I have my center point. Now let's check, is this vertical or horizontal? So what you need to do is look at your denominators and decide which one is a larger value. 16 is larger than 9. That means 16 is equal to A squared. Remember, we said A squared is always larger since it's measured along the major axis. To solve for A, you would square root both sides. Normally you would do positive or -4. However, since A is a distance, in this case, it's only positive. That leaves B squared equal to 9. Therefore, the square root of 9, B is equal to 3. Okay, since A squared was under Y, I know that this is a vertical ellipse. So I know that my major axis is going to be vertical. So what I would do is plot my center point first, 6, -3. And usually I just like to label it center. Okay, I said my major axis will be vertical, and remember, A tells you the distance from the center to each vertex. So if I count 4 units vertically from the center, up and down, those would be the points for my vertices. The B value, remember, tells you the length from the center to each co-vertex. So it has to be 3 units for each co-vertex from the center point. So that's my minor axis is horizontal, my major axis is vertical, and my ellipse is when I connect all of those vertices and co-vertices in a smooth ellipse. All right, next, example 2. Write an equation to represent each ellipse. If they ever give you points like this, like these focus points, I would automatically graph them. So I'll graph 19,3, label it F for focus, and -7,3, label it again F for focus. Since these are along a horizontal line, I know that this is a horizontal ellipse. Remember, the focus points are always on the major axis, so that means the major axis has to be horizontal, my ellipse has to be horizontal. So I need to fill in my horizontal equation. My a squared value has to be under x squared, my b squared has to be under y squared. All right, in order to fill that equation in, I'm going to need to know the center point. To figure out the center, you could count and do division by 2 and then count how far that is from each focus, or you can just find the midpoint between the focus points. Midpoint, remember, is average, so you basically average the x values and you average the y values. Obviously the average of 3 and 3 is going to be 3, but I'll just plug it into the equation anyways. When I simplify, it gives me 6, 3. So I know h is 6, k is 3, and it might be helpful to plot this center point on my graph so that it can help me find A and B. All right, I haven't used the information that the length of the major axis is equal to 30 yet. Basically, this is telling us that 2A is equal to 30. Remember, we said the length of the major axis is equal to 2A. So that leaves us with A equals 15. From there, I can add 15 to 6 to get me to 21. So I know my x value of one of my vertices is 21. Then I could count to the left 15 units to get to my other vertex. Again, it's because the A value is 15. Now, this problem didn't give us any information about the minor axis, so you might be thinking that we're going to have trouble figuring out the B value. However, since we know where the center and the focus points are, it can help us figure out what's called the C value. C represents the distance from the center to the focus. For this one, I could take 19 minus 6, so I know my C value is 13. You could also just count and make sure that's 13 units there. All right, the equation c squared equals a squared minus b squared applies whether our ellipse is vertical or horizontal. So I'll plug in c is 13, a is 15. Simplify this, 13 squared is 169, and 15 squared is 225. I'll just rearrange my equation by adding b squared on both sides and subtracting 169 on both sides. So I get b squared equals 56. I don't really need to solve it completely for b because my equation only requires b squared. All right, so I know I'm using a horizontal ellipse, so I'm filling in this equation, x minus h squared over a squared plus y minus k squared over b squared equals 1. Fill it in. I have x minus 6 quantity squared over 225. That was a squared. Oops, not equals. Plus y minus 3 quantity squared over 56, since that's b squared, equals 1. There's my answer for the equation of this ellipse. All right, final problem for today. My vertices are at -2, -4, and -2, 8. My length of my minor axis equals 10. Since it's the minor axis, that means that 2b is equal to 10. Therefore, b is equal to 5. if I know my vertices, I know that from one vertex to another is equal to 2a. So you could either find the distance between those or just count. I see that 2a must be equal to 12, therefore a must be equal to 6. So I have my a value, I have my b value, I just need my center point. So I have options. I can count and figure out where the center is, or I can find the midpoint between the vertices, which I will do just to show you midpoint formula one more time. So -2 plus -2 over 2, that's the average of the x values. -4 plus 8 divided by 2, that will be the average of the y values. So I get -2, comma, let's see, -4 plus 8, that's going to be 4 over 2. So my center point is at -2, 2. I would plot it on the graph just to make sure that it looks nice and in the middle. All right, so now that I know my center point, I know my h and k value. Since my vertices are along a vertical line, I know this is a vertical ellipse, so I'm using the equation x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. Fill it in. X minus -2 squared over b squared. I said the b value is 5 plus y minus k quantity squared over a squared, so over 6 squared equals 1. Now you just need to simplify it. So you get x plus 2 quantity squared over 25 plus y minus 2 quantity squared over 36 equals 1. There's your final answer for this equation. I hope that helps review this from Friday. I have a few more practice problems for you to complete this weekend. I'm sorry, not this weekend, tonight. I'd like you to do these practice problems, and I'll let you know tomorrow how you are submitting them or how I'm checking it. Have a great day. Bye.